And I want to introduce Ben Van Roy, who is going to be our moderator for this session and is a professor in management science and engineering. So with that, over to you, Ben.
Okay. We have a panel set up today. I think it's going to be stimulating. We have Dan, Madeleine, and Bill here. I think many of you already know these folks, but let me say a few words about them to fill in those who don't. So Madeleine here, we're lucky to have on our MS&E faculty at Stanford. Before coming to Stanford, she was a professor at Cornell, and before that, a postdoc at Caltech, and before that, a PhD student here at Stanford. So Madeleine's research aims to accelerate and simplify large-scale data analysis and optimization across a wide range of application domains. She's been recognized by a Kavli Fellowship, a Sloan Fellowship, an NSF Career Award, an ONR Young Investigator Award, and the Informs Doing Good with Good OR Award. All right, next to Madeleine there we have Dan. Dan received his PhD here from MS&E about a decade ago and has since been on the faculty at Northwestern's Kellogg School of Management and then at Columbia Business School. His highly acclaimed foundational work at the intersection of machine learning and online decision making has earned him a Nicholson Prize, an Erlang Prize, and a Lanchester Prize. He also worked for several years with Spotify, advising them on their development of recommendation systems that leverage large language models and reinforcement learning. Finally, we have Bill over there. Bill received his PhD from MS&E more recently in 2023. Well, one thing I was really impressed by when he was a PhD student here is that he found the time to simultaneously lead Meta's applied reinforcement learning team, which was a sizable group that itself included many PhDs. He also managed to win multiple awards at Meta for the impact of his contributions there. And more recently, Bill founded Pokee AI, where he is the CEO and focuses on bringing reinforcement learning to life in production AI systems. All right, so this panel is about the intersection of AI and OR. Now I find that these terms can be used in many different ways. And so for the purpose of this discussion, we'll define operations research in this way, which is a traditional definition. It's about the development and application of analytical methods to improve managerial decision making. Okay. And we'll also go with a long-time definition of artificial intelligence, which is the science and engineering of intelligent machines. So this definition originates with John McCarthy, but has really driven the mission of the field. And what did he mean by intelligence? He meant the computational part of the ability to achieve goals. Okay. Now, over the past few years, AI has really captured the imagination of the public. ChatGPT had a big role to play in this, and there's this rise of large models that has fueled fast advances in AI capabilities. And these approaches, these recent approaches, have focused on distilling knowledge from massive data corpora and reinforcement learning in order to create these capabilities. All right, so with that context, I wanted to get the discussion started with these folks. And the way I wanted to start things is to understand a little bit of how they're thinking and what they're thinking about at this intersection, and ask each of them to talk a bit about what they're doing there. And first up is Madeleine here.
So I've been thinking about AI and what it means for the future of optimization, and particularly of optimization modeling. So I think I don't have to convince you guys that optimization is everywhere, right? It's used in managing the energy systems. It's used in planning routing and logistics. It's used in supply chain. It's used in scheduling airlines, in pricing. Throughout the economy, optimization and OR tools are used to improve efficiency, particularly in sort of large-scale systems and large-scale problems. This leads to more productivity, less waste, lower costs. It's just good, right? Lower carbon. And part of the reason that I'm so excited to study optimization and OR is because I think it can have a profound good impact on the world. And so I'm interested in why optimization isn't used more broadly. Why aren't OR tools used more broadly, right? Every time I see waste or inefficiency, I say, why can't we solve this problem? And I'd say the main thing that limits the use of optimization and OR is actually not that it's too hard to solve the problem, although that's what most OR experts in academia spend most of their time on. It's actually that it's too hard to write the problem down. It's too hard to figure out what problem you're solving. So here's an example. This is a very simple production planning problem. So this, I'm not going to read it to you, but this looks maybe like a problem that you might have seen on homework in an introductory linear programming class, right? This is a very simple problem, and in your introductory linear programming class, you probably had to model this problem. And I'm not sure, did you model it in GAMS? Did you model it in AMPL? Did you directly write down the simplex tableau? It probably depends on when you went to school. Okay, but you can imagine a manager at a large company articulating this problem. What you can't imagine is them articulating this problem. So this is the same problem written down in Gurobi Pi, which is probably the technology that you'd use to write down the problem today. If you execute this Python code, it'll solve the problem and give you the solution, okay? So this is one of the things that limits the use of OR. And it wasn't, somehow this is about the simplest interface you can imagine in the pre-language model era. But now you can imagine actually much simpler interfaces. You can imagine directly typing in the text and getting out the answer. So we developed a system that we called Optimus for optimization modeling using solvers, which is a project to automate optimization modeling and a collection of open source tools for building an optimization copilot. So I'm going to walk you through how this works using a demo in this web app. And now let me try to find where this is on Ben's computer. Here we go. Okay, so this is optimus-solver.com. You can go here and you can try out your own optimization problems that you may seek to model, except I thought I pre-populated this and it's not pre-populated. So this is what we can do. Actually, maybe this is more exciting, but I won't be able to finish the demo in time. So you can paste in your description and you can analyze it. And usually it says this might take around 30 seconds. So I think I'm not gonna wait for this. But after it's analyzed, it will populate parameters. Okay, so it says, here are the parameters in your problem. There's an upper limit, a production rate, the number of products produced by the factory, increment in tons by which each product may be produced. Right, you go through this. And it's very important with AI, if you want to get things right, you can't just trust what it tells you. You have to check. So all of these fields are editable. So, for example, maybe it's not an increment in tons, maybe it's an increment in pounds, Okay, but no, I'm going to go back to tons. I can also delete these parameters if they're not right. Okay, and then I can extract the objectives and constraint from the problem. So the objective is to maximize the total profit from selling all products. And here's the list of constraints. Again, I'm not going to read them to you, but in this case, they're all correct. Okay. You can formulate each of these constraints. So here I can click this formulate button to produce a formulation in LaTeX, right, as a mathematical optimization problem, and which is compiled over here, so I can check and I can make sure that each of these is right. Now, if it's not confident about the formulation, it'll actually highlight this in pink, right, to encourage me to not turn off my brain and actually think about it. But in this case, it's quite confident. They're all right. Fantastic. It's extracted that there's two variables in this problem, production quantity and integer quantity. Okay. You can go to the next slide. It codes them all in GarobiPy. Okay, so they're all coded. Now I can test. Now, if I don't, I might have data for this problem if I actually want to solve it, but if I'm just testing it out, maybe I need sample data. Actually, this is one of the most difficult steps, is coming up with a good sample problem that really gives you intuition for how the model works. That's ongoing research, but here we have a really simple version of it. This is not going to work because you can see that the lower limits are, in some cases, higher than the upper limits. Okay, so maybe I should try, continue with this data, and if I do and I run the code, it's going to say it's infeasible or unbounded, right? Okay, so I can go back and fix that and iterate right here in this interface and try adding new constraints, editing the model. I think this is really powerful for consulting companies that often will go into a business and create an OR model, and then they leave, and the model, the problem changes. Something changes in the business, and the business doesn't know how to update the model. And so an interface like this can help make it easier for people to sort of interact with their model in natural language. But there's clearly a lot more that needs to be done. And I would say that as we've worked on this, one of the things that, the challenges that really wasn't on my radar before we started this, and now is, to me, it seems like the most important problem, is that it's very hard to articulate an unambiguous problem in natural language. So we said, we want to do the machine learning methodology. You take a bunch of problem descriptions and look at model formulations. And see how often are we doing the right thing, how often are we getting it right. Actually, there's no good corpus of large numbers of optimization problems, and as you collect more and more of them, actually more and more of them are ambiguous. It's not clear, the problem is not completely specified. And so we've actually started doing qualitative research with OR experts, and indeed, OR experts are spending most of their time not on solving the problem, but on going back and forth with domain experts to try to figure out every aspect of the problem. Usually when you first write down the problem, you're missing constraints, you're missing parts of the objective. There are implicit assumptions that you forgot to encode. And that's extremely important. And I'd say it's also important from the perspective of AI safety. I don't know if you know this classic thought experiment, which is, suppose I have a all-powerful AI assistant that's hooked up to robots and manufacturing and whatever, and I happen to own a paperclip factory. And I say, well, what I'd like to maximize the production of paperclips, right? Okay, what happens? Well, if it's really a fantastic AI, right, it commandeers all of the energy resources and all of the material resources on Earth to produce paperclips, and in the process, killing all life on Earth. Okay, so there was an implicit constraint that I forgot to encode. Okay. So I think that optimization and OR generally can actually inform debates on AI safety, and figuring out how to get AI to query domain experts and ask them what they really want is really integral to AI safety. I'm going to pass it to.
Okay. Yeah. Thanks very much. That was very interesting. And so my take is Madeleine's making it much easier for us to use optimization tools and go from unstructured problem descriptions to optimization formulations. That's powerful stuff. Dan started the Columbia Agents Initiative, which takes a different tack toward automating decision-making using AI tools. And so it'd be interesting to hear about what you're up to there, Dan.
Thanks. Yeah, so I first of all, that's really super cool, and I think you're really democratizing tools we care a lot about. It's amazing. So I had some debate about whether to share sort of research I'm working on or share, things I've been a part of at Spotify or so on, and I decided that for the purposes of kind of the discussion of this panel, it'd be better to think kind of big picture about what myself and these other PIs are thinking are long-term deficiencies in the way kind of the most hyped AI is being developed right now. And what we're doing to address this is partly going about our own research projects, but we wanted to also try to create an ecosystem at Columbia where smart postdocs come in and they come up with ideas we didn't have, and kind of all around this theme. All right. So to kind of set the stage, I'll build kind of a caricature of how I think most of the big companies have been building their AI systems. And I want to highlight that this is a particular paradigm of how to build AI. It's one around imitation learning. Okay? So say I want to learn to create a computer agent that can write code very well. The way that people are going about that is by leveraging the fact that lots of humans spend a lot of time coding. And you have lots of experts out there, and you have medium-scale experts out there. And their work has been digitized and documented. And if you have access to GitHub, you have access to all of it already. Okay? So then you get a computer basically to sit there and read the code. It's like you have your blinders on, it's flowing past you, and you learn passively as this data washes over you. And the training objective there is that if you masked out part of the code, this agent wants to be able to predict what's missing. Okay? And what I would have thought is a deep deficient, like a clear failure mode for this, is that lots of the code you'd find is not good. Right? And maybe it would not be a helpful coding assistant because I don't want random code. It turns out, and this has been the shocker for me at least, that foundational capabilities emerge through this training process. And you can do a little bit of the second step here to reorient this model to write maybe more verbose but clearer code, or better commented code. And almost as a mental model, imagine there's a little knob that says how many comments are there, and you can carefully tweak the model to have some of these properties. Right. Now, if you listen, though, to the long-term vision of AI that Ben mentioned, that is one where intelligent entities are out there accomplishing tasks in the real world. And some of the tasks we'd like them to accomplish are not things that humans professionally do and are recorded doing massively at scale. And so I don't see how that paradigm would fully solve the problem. Okay. And I myself have used recommender systems as like the technological frontier that looks like this. But for the purposes of this discussion, I thought I would cast a more optimistic vision around education. So something I have in the back of my mind as I try to think about research that's like long-term and could be transformative is I have a 2-year-old son. I expect that by the time he graduates high school, he will be, in deep and meaningful ways, tutored by AI. Okay. And if you actually had a massive tutoring system that interacted with lots and lots of students and interacted with each student across time, that should be an opportunity to build an educational system that's different from what we have today. Couldn't be imitated. Okay, now, what do you need to be able to do that? You need to be able to learn interactively, learn to kind of gather your own training data by interacting with different people. Each time you face a new student who signs on, you have continual uncertainty because you don't know their learning style, you don't know their abilities. Maybe they're trying to learn a subject you haven't tutored before. So you need to be able to probe judiciously and learn to resolve this uncertainty. Now, what do you optimize for? This is a big issue in recommender systems. Are you optimizing just for the next click? I think you can feel that often they are. But this tutoring system should help drive toward long-term outcomes. What signals do we have that learning is really happening, that they're developing the skills you want? How do you get the system to accomplish these long-term, murky, ambiguous goals? Okay. So some of this stuff to me all feels like a space for academics, for the research frontier, because it's not easy to imagine that someone with a 6-month deadline is going to push this stuff. And we're trying to get enough of an ecosystem at Columbia to push it. Thanks. Does this work?
Yeah.
Okay. Thanks, Dan. That was very interesting. And so Bill,
All right.
Bill here is running Pokee AI and says he's developing a foundational reinforcement learning agent that can automate business functions for all of us. So I'd love to hear today more about what you mean by that.
Yeah, thanks. So there has been a lot of definitions on what AI agent is about, right? And then Dan and Madeleine all discovered like sort of like verticalized version of AI agent that can either solve like recommender system for you or solve optimization problem for you. But when we talk about foundation AI agent, that it really is about it can plan and execute on a very long sequence of workflow and tasks for you. It can seamlessly integrate with all kind of diverse set of tools that you can put into the agent. For example, if you're in a social media workflow, you basically say, oh, can you actually post for me on Facebook, Instagram, LinkedIn, Twitter on my behalf and run the entire social media campaign on my behalf? Or if you're in education, can you say, can I deploy these homeworks to the student and actually evaluate their outcomes accordingly? Or if you're in optimization, can you run these kind of LLMs to actually generate the problem definition, transform it using Madeleine's tool into something that's a solver can be solved, and then use the solver to solve the problem, put together a slide deck saying, here's how I'm going to solve it, and then present it to the leadership, right? Can you do all of that with a single agent? And lastly, we also want to completely eliminate all the rigid workflows that people are doing right now. Like you have to manually specify step 1, like write a whole article about it, and then give it to someone. Step 2, so on and so forth. So that's the foundation agent that we're talking about, but then why we're not there yet. So a key thing that we have been identified through using large language models, especially the state-of-the-art, including Cloud, GPT-4, and so on and so forth, is that the internet scale tools is not just dozens, not hundreds. It's actually tens of thousands, if not hundreds of thousands of tools across the internet. As an example, for example, if you want to actually use an AI to operate Google Docs, it's actually not just a single tool. It's actually 150 tools that you can actually use to operate a Google Doc. Now, if you look at the chart I just showed here, all the state-of-the-art models that's out there completely start to fall apart after like 1,000 tools. That means even if you want to operate on, let's say, just the Google Docs, Slides, and Sheets family, it can't do it anymore. Pokee, we built this foundation model that is really good at using tools that can really redefine how agents, AI agents, can really operate across the internet so that you're no longer just generating content. You're actually having an agent that can autonomously carry out workflows and execute on your behalf and really sort of streamline all of these daily professional activities that we are going through. And what's better is the fact that you can't scale if your cost is actually going infinite as you scale the number of tools. So let's assume that if you actually have something like Cloud that's running across, let's say, 100,000 tools, it costs more than $20 to run a single execution. And that's not going to be helpful because if you hire someone to do like a simple workflow, it's less than $20. You might as well just hire a human to do it than asking AI to do it. The whole point of using AI is efficiency, cost effectiveness, and so on and so forth. Right? We want to scale to the internet scale in terms of tooling so that it's sort of almost constant cost, no matter how many tools you slap at an agent. So these are just stats that I'm trying to show here, but I also want to sort of briefly present the latest research result that we've got in action so that you guys see like how, as a human, you can use this tool. So there's this YouTube video that I put together that you guys can, I'm going to just quickly walk through it. This is sort of a UI that you can literally play around with. That's sort of similar to ChatGPT. But then here's the prompt I give it, saying, can you deep research the relationship between AI and operations research, fetch relevant images, create me an 8-page slide deck, create a Google Doc as well, and then we all know that people, especially academics, live on Twitter now. So can you actually create a tweet for me as well, in addition to all of that? And start to understand your prompt, build the entire workflow together, understand all the requirements, and then boom, you have a workflow. So it's actually able to break down into like a very comprehensive, long workflow and being able to execute step by step using internet tools, Python packages, JavaScript packages, offline integrations to make all of that happen in a single click. Now it's performing deep research to understand the relationship between AI and OR, citing the right articles, understanding what's really going on. Just a disclaimer, I did fast forward the deep research part because it does take 5 minutes to complete that. We don't want to sit here and watch it like spinning. But the second step, you get the images, and now it's generating a slide on your behalf. Surely you'll be able to see the slides. All right, almost there. All right, let's look at the magic. So this is a slide you just generated through everything that was just searched, retrieved, and then sort of put together in a really nice format. It's basically something that you can already present at a conference. And then you have a Google Doc as a report. Yeah, it can do basic deep search and stuff right now. We are actually improving it so that it can actually go into really deep into every single document to find the information you need. And then now you're going to have your Google Doc very soon. All right, there you go. Very nicely formatted, markdown format that you need everything you need in a single document. You can present it to your leadership already or present to your department chair. And now, Twitter time. Going to generate a short and catchy phrase and then attach some images and then post it to Twitter. All right, 4 images, nice catchy tweet, and there we go. This is my Twitter account, and then you can still look me up. Let me just go back to that. That thing I posted 2 nights ago, and then it's still there. I purposely didn't delete it, so you guys believe me that this is real. So you guys can look me up. It has all the nice images we just retrieved, and it's able to take everything on your behalf in a very short time frame. So the whole thing takes like less than 5 minutes. And you can imagine if you were to do it as a human, it will take hours, if not days, to get everything done. And I think the future of AI is really about decision making and being able to use tools, the right tools, in an efficient fashion so that we can have a truly autonomous workflow being done by AI. Cool. Yeah, that's hopefully you guys enjoyed the video.
Okay. Thank you.
Yeah.
Okay, so this is very interesting, guys. All these initiatives are just really, we could talk forever about this. But let me start with one question that is oriented around the theme of this session, which is I'm wondering whether you think developments in AI are going to substantially change the way operations researchers in industry go about their work. And if so, what's the most significant change you anticipate? Let's start with Madeleine.
I think that developments in AI are going to change the way that we do almost all white-collar work, and that certainly includes operations research. I would say that probably the soonest change that I expect to happen is the change to the way that we do sort of presentations or digestion of information. Sort of along the lines of Bill's presentation. I think that in areas where we really need to get things right, and where there's a notion of right and wrong, I think it's going to take longer to figure out how to integrate AI in those areas because of the problems of hallucination and unreliability of the tools that we have, and figuring out how to get AI aligned with human intention, especially when we're bad at expressing it, is going to take longer. But I think that will happen. I think that most of the tools that we use right now could be replaced by AI if we have enough data to train that AI on, which I think is the other sort of big wild card, is whether we can, for any given task, like, is there enough data? Is it possible to sort of transfer what the AI has learned across other domains to be able to tackle tasks that have very little data? Or are there some sort of tasks where the data is so compartmentalized that humans will continue to be better than AI at those tasks?
Want to add something, Dan?
Sure. Yeah, I think that, maybe as a cop-out, I'll give kind of a short-term and a long-term answer. I think in the short term, you can kind of already feel changes to, like, if you're analyzing data and writing little Python scripts to do that, it's so much faster. You can have Claude or something write a lot of that code for you. For looking up and learning things that are a little bit new to you, I find it's very useful for editing, writing, for grammar, presentation quality, and so on. It's very useful to me. So a lot of that is not specific to OR. Something that I think in the longer term will change kind of what it means to do OR is OR has been very rooted in a world where the information that is ingested to make a decision comes from a data table. And so the data you can use, the kind of information you can leverage has to be very structured and very clean. And you're usually imagining that what the output of your system is also very structured and very clean. It's like a vector of how much to order at a bunch of locations or something. And we're, I think, clearly racing toward a world where the way we interact with technology is different. I take a picture of a piece of fruit in my house and speak to my phone and say, I'm wondering kind of like if I would get sick if I eat this. And it analyzes the picture and describes what the risks are and are not. And you could certainly imagine that it tried to probe my risk tolerance and so on. And that is decision making. You can imagine lots of things that involve data that's of this type. And most data in the world is of this type. And OR is going to have to change, I think, to be relevant, to stay relevant, to kind of leverage this kind of information.
Cool. Yeah. I'll take a little bit a different approach to talk about this problem because I'm sort of really deeply embedded in all the AI fields. The first thing I think is how OR people typically want to describe a problem is through very analytical ways of describing the constraints and objective functions. And then typically in the real world, we try to simplify all the assumptions so that as a human, you can process all the constraints. But in today's AI world, constraints are no longer a limitation by a human. You can actually use LLMs to generate dozens, if not hundreds of constraints, and then use trial and error to actually figure out what constraints actually validate with each other so that you can actually just give it a very clear descriptive description of what the problem is, and actually have the AI generate the entire configuration of the optimization problem. What's even more is that a lot of these optimization problems themselves are not solvable or tractable by standard solvers. Now, how do you deal with that? There's a lot of approximation solutions today that you can actually approximate these results without having an exact solver. You might not have the optimal solution, you have a suboptimal solution, but it's still feasible enough for real-world problems. I want to give one example that we actually did when I was still at Meta. So this paper is open, so you guys can look up. But the idea is that there's a bunch of data centers across Meta, right? And then you want to basically be able to say, okay, there's some machines that's about to retire. And I want to make sure there is a procedure that can migrate one data center, machines from one data center to the other, and then also have machines that can substitute these retired data centers so that I make sure my data center is always available with the lowest possible cost. And you can imagine that if you want to put all the constraints across the entire United States or the world on all the data centers, plus the objective function of lowering the cost of different kind of configuration and everything, that's going to be overwhelming. There was an optimization group within Meta that have been trying to use standard solvers to try to solve this problem, and then they tried for a long time, wasn't able to find any solution. And it turns out my team, as an RL team, sort of chiming in and say, we can actually just build an RL solution that actually just keep trial and error on the solving part, and then no matter how big the constraint you're going to slap at me, I'm still going to find an approximate solution for you. So in today's AI world, a lot of these what we call approximate and suboptimal solutions is actually really good and good enough for real-world practical problems. And I think a lot of the OR problems is going to eventually go into that direction where you're not going to find exact solutions for every single configuration of optimization problems in the world, but you actually can find the synergy of like what is the typical format and what is the typical workflow you can actually get like a general solution with.
Thanks, Bill. That's a very interesting point you guys made. Wanted to pull on a thread that Dan started with his comments. He talked about how the tradition in OR is to work with structured and clean data. And related to that, I think, is that the tradition is to work on domain-specific models that are really designed for a task at hand, right? The trend in AI over the past few years has been to leverage massive data corpora, often with quite unstructured data, and to use that to produce very general models that are effective across domains. And so I'm wondering whether this trend in the way modeling is done in AI will influence how modeling is done in OR. Want to take a stab at that?
Sure. I think that one of the major limitations for the sort of data-first, sort of big data across domain approach in operations research is the accessibility of the data. If you want to train a model on a ton of data, you need a ton of data to begin with. And as we've been exploring the Optimist project, we found that OR really seems to be quite data limited. The number of really big, realistic problems that you'd like to be able to at least test on, if not train on, most of them are proprietary. They're not in the public domain. They're not on the internet. And so I think it'd be very hard to train on these. There's some companies that have access to a large collection of these problems. These are the major modeling companies. So places like Gurobi or Ames or Cardinal Optimization. And so it's possible that they could build something that goes across many sectors. But actually, even within these companies, they find that their clients really concentrate in particular sectors. There's a lot of supply chain, for example, whereas like I don't know, people who have problems in airline pricing go for solvers that are specific to airline pricing. So again, like the data has been sort of concentrated and partitioned. I think that's going to be a profound obstacle. But I think the question in many areas of AI training is a large collection of not very good quality data, does that beat a small collection of extremely high quality data? And it's a quantitative question. It's not obvious to me which way it's going to go.
So, okay, this is a characteristically deep and difficult question, Ben. I think it's the future is murky to some extent here, and the main variable that I puzzle over is indeed the availability of data that reflects broad swaths of problems we care about, and how to generate problems that reflect the problems that we care about. But one thing I can touch on that's kind of like halfway to OR and doesn't maybe seem like language or something is coming out of stats. I think stats has also been often very focused on particular domains and so on, and really on tools that a professional data scientist would use, not tools that can be used by a layperson. And one thing you've seen recently are several variants of large AI-type foundation models for statistics tasks. So there are foundation models for time series and foundation models for predicting things off of tabular data, and probably soon a foundation model for both. And it's pretty competitive with a data scientist who knew many different methods, coded them all, tried to tune which one to pick on which data set. You just throw in the data, it produces a demand forecast for you. It's surprisingly good. Okay, and you know, so I think that points to this opportunity to build OR tools that are like this and very easy to use and work across many problems, but I don't have a path forward to it.
There's something still to think about.
Yeah.
It'd be a good research topic.
Yes.
Do you have anything you want to say about this, Bill?
Yeah, I'll touch on like a very quick point. I think the notion of specific problem formulation is not like a black and white thing. Like, for example, if you think about LLMs, they solve completely different problems from like recommender systems and so on and so forth. So I tend to think there is not really a line that says this is an OR method, this is an AI method. And there's some gray line in between. And then, for example, many years ago, we don't even think that like LLM is a feasible thing. And then now LLM in the problem formulation of token generation is now sort of a trending thing. But then a few years later, we might formulate the problem a little bit differently. So that's sort of OR-ish already to its own merit. Another thing I also want to say is a lot of the AI innovation itself comes from OR formulation. One classic example I always talk about is safe RL and safe like planning and stuff. The notion of MDP, Markov decision process, and constrained Markov decision process is the core of all the safe RL innovations. So a lot of the OR mathematical framing itself brings life to today's AI innovation. It's not like we don't even need specific problem formulations anymore.
Thank you. So I wanted to pause up here and take a few questions from the audience. So you can ask these experts questions on your mind. Yeah.
My name is Bob. I need to wait for the microphone. We're streaming. I know. Come in early. PhD OR. Thanks. My understanding is that AI lacks a scientific basis for defining intelligence and assessing improvements in intelligence. Is there any contribution we can make from the OR side to push that along? Thank you.
What do you guys think? Can we clarify what we mean by intelligence?
Yeah, you have to define what you mean by improvement in intelligence itself before we can even have a discussion of that.
I would say, many of the improvements that we've seen in AI over the past decades have been driven by the development of benchmarks. Right? You say, here is the set of problems. If you could solve this set of problems, then I would be impressed. Okay? And then people work hard on solving that set of problems, and then at the end, either you're impressed or you say, oh, that wasn't actually intelligence. Actually, this other thing is intelligence. You make a new set of problems, right? And so I think OR, the standard way it could contribute in the context of sort of this ML approach to intelligence is to develop benchmarks. Say, here are some hard problems. Here are the problems that we would be impressed by as OR experts if AI could solve these problems.
Yeah, so to riff off that, I think one of my slides had this list of, I think not super scientific, but vague kind of capabilities that you would, that are stressed in MS&E of dealing with strategic interactions and or the ability to quantify your uncertainty, and so on. And you could build benchmarks targeted at each of these capabilities, and I think some of the methods we are popularly using today fail at these things. But I'm not sure that goes all the way to improving the Turing test. Yeah. It's a shorter.
Curtis had a follow-on question.
Yeah, when I look at AI,
Oh, sorry, Curtis, you got to wait for the microphone.
Yeah.
the history that I know, thank you, courtesy. The history that I know, AI was born out of operations research. How do you feel about that?
Proud.
I'm thinking neural nets. Neural nets sort of came out of
Yeah.
I know when assistant professors were getting fired because they were doing neural nets and it looked like they were going nowhere.
I feel like it's a combination, right?
I was almost one of those, but okay.
Called Madeleine.
That's right, there was.
Yeah. I think it's a combination. So we can't just say that OR is sort of the source of AI. There's a lot of analytical methods and optimization methods that powered how AI has been today. But without the scale of compute, without the scale of data, there's no AI. So it's a combination of analytical methods that come out of OR and statistics and computer science methods that build the software and hardware behind everything, the electrical engineering methods that build the chips that powers all the compute behind it. Put together, that's AI. So I wouldn't separate them as like, oh, this thing come out of OR, or this thing come out of EE, or this thing come out of computer science. I think it's sort of like taking a split view of what AI really is today. That being said, I'm extremely proud to be in OR, coming out of the OR department as a PhD, to be deeply in the AI world, because I think I have a more analytical view of the problems I'm solving than a lot of maybe like pure software engineering or ML engineering approach that they just throw data at a model and then hopefully things stick. So I agree with Dan that I'm really proud that we have this training to be able to understand problems in a much more sophisticated way.
Thanks. So I'm really curious about the deep research work. When search engines came along, we started producing content such that the engines could most easily find our content. Now with deep research, is there now going to be a new industry like deep research optimization, which is creating research such that these deep research engines can find it most easily and you get more references? And if you do see a future like that, what do you think are the certain things that you want to make sure you include in your research so that it's easy to find?
I guess I'll take a stab at it first. I think it's a very tricky question because you can always be like recursively say, I have a deep research agent that needs to do deep research to understand some other deep research topics. So it's not very obvious how you would actually structure this problem. But the way I think about it is it's not that different from the traditional search engine in the sense that traditional search engine, what they do, they take the entire internet, index everything into smaller chunks so that they can retrieve the information and summarize. Now what you do, you have sub-agents or sub-workflows that kick off the search workflow, find certain information that's almost like an index to yourself, and then you try to merge them. You can always build a tree infinitely like that, and then you can basically be able to fetch any detailed information across the internet in any scale fashion. So I think that's sort of the future in deep research. But that being said, just being able to retrieve information on the internet doesn't mean that you already solve the ultimate problem, which is you might not be only solving one research problem. You might be like, I have 3 things to be built so that I can finish my research. So then how do you connect these dots that becomes a bigger problem?
Let me follow up on Curtis's comment. So, so the field of AI, as I understand it, is not defined by methods, but by what the field wants to accomplish, which is to understand intelligence, whatever that means, and reproduce it. And so over the many years that you have in mind, Curtis, the field has iterated over methods produced by various communities to see if that could be helpful to accomplishing what they want to accomplish. And indeed, methods from OR have played a large role in all of that. In the most recent wave of deep learning and large models, for example, step size adaptation rules, momentum terms, those sorts of things have played an important role in making algorithms work reliably. And those ideas have roots in OR. The transition from sigmoids to ReLU activation units were partly motivated by and deeply connected with ideas in convex optimization. And these innovations that sort of drew on ideas that came out of OR have played a major role. So let me ask this. Going forward, what else from OR might contribute critically to AI?
Let's always go in the same order. I think that's a safe way to do it, yeah.
So, I mean, one thing that I guess is top of mind, maybe for MS&E more broadly, I think I missed your name, sir, but you made this nice comment of people changing the content they create based on AI being deployed. There's one area that I think OR has stuff to contribute in terms of AI development, for sure. But I guess where I'm taking it is more in terms of what happens as you deploy and how to deploy it and so on. Definitely this department has a lot to contribute. Like just a hypothetical example, if you think about online labor markets, if suddenly the communication channel becomes very frictionless, you can send messages very easily, you can respond to messages very easily, that seems great. But that removal of frictions has lots of negative consequences to signaling, to how the market operates, and so on. And so I think there's a lot of work to be done in terms of how you structure interactions that are partly mediated through AI. And that's one place.
I guess I'll touch it. So I think there are two things that are really important. One is that, going back to what I said about specific problem formulation, I think OR people typically has a much stronger sense of how they formulate problems in a much more analytical way. I do think the next AI wave might not just be LLMs, might not just be diffusion models. Can someone be able to construct a problem in a different formulation that is a lot more general or a lot more specific, in either terms, because it could be very general to solve a more general kind of AI problem. It could be a very verticalized solution that's no one else can solve, maybe in the medical field, maybe in the legal field, right? So can people really be able to sort of formulate exact exact problems for AI to be helpful in those sense? That's one direction. The second is I do think a lot of these mission critical stuff that we work today requires exact constraints on certain things cannot be done. For example, if we're doing airline scheduling or we're doing verification on autonomous cars, right? Can we actually make sure that these constraints are never being violated through our optimization, through our learning process, training process? That's actually really, really important. And if you use a pure foundation AI model and then just slap the whole thing at the model and hope for the best, typically don't have that constraint. And then in an optimization world or in an OR world, you can actually design these constraints to make sure that not only it can have a general solution, but also have these constraints that satisfy real world constraints, that not have crashes in planes, cars burn down, all kinds of situations.
Thank you.
Yeah. I mean, I would say that ideas from OR that I really hope will be integrated into sort of next level AI systems are things like risk, constraints, robustness, incentives. Right now, the way that AI models are trained really is you throw everything into the objective, you take all of the data, you want to get all of these things right, you put them all in the objective, and everything's kind of weighted evenly. And that's not the way that you can protect against tail events. It's not the way that you can ensure that certain constraints are satisfied. It's not the way that you make a robust system, and it's certainly not the way that you make a system that's sort of that's immune to gaming or to bad actors. It's really dangerous to build systems in the way that we've been building them, and the little sort of tweakings along the edges clearly don't get at all of the potential for, even the sort of the filters that have been put on these LLMs before we see them. They're so easy to jailbreak because they're not trained in a robust way that really does respect constraints. Now, this is something that OR is excellent at, and we know a lot about how to exactly enforce constraints, and we know that it's not by just throwing it all in the objective and putting some weight in front of it and hoping for the best. But we do have actually really good methodologies for ensuring these kinds of properties. And I think that's a really important direction for research in the future.
Thanks. I think we have time for another question from the audience. Sir.
Suppose you consider using AI to expand the problem space beyond what a traditional OR model could deal with. For example, in airline operations, when there's a significant weather situation, it causes what they call in the industry irregular operations, meaning a lot of delays or cancellations of flights. And in order to rebalance their schedule, they have to consider everything from aircraft availability to the number of hours that pilots and flight attendants are allowed to fly per 24-hour period. But airline passengers are very frequent users of social media. And social media postings are a proxy for customer satisfaction or dissatisfaction, but you can't put them into the traditional OR models that airlines have been using for 25 or 30 years. But could you have an AI companion analyze the social media postings in real time and make them a variable in the model?
Yeah, you certainly can. Like I said, there will be more approximate solutions to different type of formulations of OR problems. And then I do believe a lot of supply chain problems, airline problems, basically all of these optimization problems people are running today have exact format. It's almost like, here's the input, here's the output, and that's it. But imagine a world where you have is, I can generate all the constraints myself on the fly, given all the environments that's out there. I formulate a optimization problem, and I use some AI method to actually generate a sort of approximate solution to that, and then deploy it. That's sort of the autonomy that we're looking for through AI and OR together. OR is sort of, in this sense, a guardrail of how you should formulate this problem for these companies. So that's sort of my view of it.
Yeah, I mean, I'll just add this comment that I feel like almost every domain has a lot of low-hanging fruit, exactly of the type you mentioned, of just information that we didn't know how to use before, that is out there, and you could probably have a lot of impact going around creatively finding these like this one.
It's also a great example of a problem where you don't have months and months for OR experts to chat with domain experts and figure out what the right problem is to solve. Right? You need more automated tools to be able to solve that problem now and get the planes back in the air.
All right, so this was a lot of fun. I want to thank the audience for the engagement, which is great. And thank you very much to the panelists.